In example 1, we're asked to differentiate with respect to x. So my WRT, that stands for with respect to. Let me do the middle one and you do the two at the ends. All right, so for the middle one, dy by dx, bear this in mind. Whenever I differentiate e to the x, I'm going to get back e to the x. So this is 3e to the minus 2x. If I differentiate e to the minus 2x, I'm going to get back e to the minus 2x. But I must also multiply by the differential of the inside function. Minus 2x is the inside function. If I differentiate minus 2x, I'm going to get minus 2. So dy by dx here would be equal to minus 6e to the minus 2x. Please do the one on the left and the one on the right. Please do the one on the left and the one on the right. All right, so you need to remember whenever you differentiate e to the x, you're going to get back e to the x. However, if you have an inside function like here, if it's a composite function, if your e function is a composite function, and there I just identified the inside functions, 4x on the left and 3x plus 5 on the right. You have to differentiate the outer function, which is e raised to some power, and you have to multiply by the differential of the inside function, and that is chain rule. So here, dy by dx would be equal to e to the 4x, and I have to multiply by the differential of the inside function. The inside function is 4x. When I differentiate 4x, I'm going to get 4. So my final answer is 4e to the 4x. To the right, dy by dx, I have 6e to the 3x plus 5. When I differentiate e to the 3x plus 5, it remains the same. Then I have to multiply by the differential of the inside function. If I differentiate 3x plus 5, I should only get 3. And 3 times 6 is 18. So this is 18e to the 3x plus 5. Did you get those, guys?
Yes, sir.
All right.
Yes, sir.
Very good. All right, chain rule. All right, chain rule, this says function of a function. And now chain rule is when you have a composite function. You have a function inside of a function. So what you normally do is that you normally let the inside function be equal to u. And then what you do is that you differentiate. So if I did that, if I let g of x be equal to u, what I'm going to have is y is equal to f of u. So what then I would differentiate now y with respect to u. So dy by du would be the first differential of f of u. Now, then now I'm also going to differentiate u with respect to x. So I have u is equal to g of x. And so du by dx would be equal to g first prime of x, the first derivative. Now, dy by dx, because I wasn't asked to find dy by du, I was asked to find dy by dx. Dy by dx now would be equal to dy by du multiply by du by dx. All right. So let us see an application of that. A question similar to the one that we just did. All right, so I'm coming down. I'm going to do this question using sort of like the formula approach, a formula approach. So I'm going to say, this is my composite function. I'm going to say, let u be equal to 4x squared plus 3. This is my inside function. All right, so du by dx would be equal to 8x. Do you agree? Du by dx would be equal to 8x. Do you agree?
Yes,
So
sir.
when you differentiate 3, you get 0. All right. Now, y would be equal to e to the u. And remember, when we differentiate e to the u, with respect to u, we're going to get back u. So dy by du would be equal to e to the u. Now, we were asked to differentiate y with respect to x. That has nothing to do with u. So I need to find dy by dx. dy by dx would be equal to dy by du multiplied by du by dx. So dy by du is e to the u multiplied by dy by dx, which is 8x. Bring the 8x to the front. I have 8x. And this is e to the u, which is 4x squared plus 3. Now, I can tell you straight up, if anybody asked me to do this, I would not do this. I consider it to be a waste of time. I would not do it this way, not this question. Are there questions I would probably consider doing this way? Yes, there are, but not this one. Coming, just writing it. X squared plus 3. Are there questions that I would consider doing this way? Yes. Would this be one of them? No. This is how I would have done this question. First of all, so I have y is equal to e to the 4x squared. I find that sometimes this thing just don't write properly. Doesn't work well all the time. Something that's very annoying. All right, so e to the 4x squared plus 3. Now, first, I would have to recognize that this is a composite function and that 4x squared plus 3 is the inside function. Whenever I differentiate a composite function, I would differentiate the outer function and then multiply it by the differential of the inside function. The outer function is e and or e to the u, and if I differentiate e to the u, I'm going to get back e to. So dy by dx straight would be e to the 4x squared plus 3. And I have to now multiply by the differential of the inside function, which is 8x. Then I would write my answer to be 8x e to the 4x squared plus 3. This is how I would have done it. Doing it this way is not always the safest, so it's always good to know the other method, but this is how I would do it, especially for questions like this. It saves time. I don't have to go through all this cumbersome thing that I just went through. All right, so let's get your opinion on it. I'm going to stop the recording.